3, 2, 1. Hello, this is Niswander, and you are watching the Nowman Show podcast version in this particular episode, and we've got a great one here. A returning guest to the show, Erika Podest from NASA, Earth scientist. Hello, Erika. It's great to see you again.
Hi, Dan. Great to be back.
Fantastic. This is your fourth time on the show.
I feel like a seasoned veteran.
Yes, you are. And it's been way too long since we've been able to talk, and there's so much to catch up on. So a little bit about yourself. When we first met, it was at the Green Festival in Los Angeles. And I just couldn't wait to get you on to learn more about exactly what's going on at NASA in studying climate change, because as we all know, this is extraordinarily important, to say the least. And you talked a lot about working on at that time, gosh, that was 5 years ago.
Wow,
right?
Time flies.
You were just beginning to work on the Smap satellite, which was the soil moisture that analyzes the moisture of the Earth, right? Twice a day.
That is correct, yes.
And we talked about that. And first of all, we have to start with the unfortunate facts that we cannot deny. And 2019 was the second hottest year on record. What was the first?
2016.
Really?
Yes.
So they're both like now, basically.
Yeah, the trend is consistent. Global temperatures keep going up. We've got the hottest decade on record has been the past decade. 2019 was the second hottest year on record. 2016 was the first hottest year on record. It's very concerning.
So what? That being said, what are the implications of that? I mean, what can we expect to be happening now?
Yeah, so that has tremendous implications on our planet. Global warming is the cause of climate change, and all of the changes that we're seeing on different ecosystems around our Earth, our planet. And one of the areas that's being primarily affected, it's ground zero for climate change, is the Arctic. This area is warming up at least twice as fast as the rest of the planet. And that has huge implications. You've got a lot of ice on land. So you've got Greenland has kilometers of ice sheets, and that ice is melting. And when that ice melts, that water ends up in the oceans, and that's one of the causes of sea level rise. So, and there are many other things that are occurring. You've got sea ice that's melting, that's being lost. So the sea ice cover is declining. It's about 13% per decade. And in the future, it will probably be the case that in the summer, it'll be ice-free in the Arctic.
Wow. And I know one of the things that people try to debunk sometimes is the idea of global warming, right? Which is why the conversation shifted to like climate change, just like climate scientists, to earth science. It's all the same thing, but it's like, and because people say, well, it was freezing cold here last winter. I mean, like, people on the East Coast or whatever said, we were down in the below freezing for long periods of time. There's no such thing as global warming. That's not global warming. It's colder. And it's extreme weather, right? Extreme temperatures. Just like if you were to, in your own human body, you would put a hot cup of coffee in your body. It's going to have the opposite effect, right? In lowering the body temperature or raising the body temperature, depending on whether the input is cold or hot, right? How would you describe what really the effects of global warming as far as the temperature is concerned when people have those kinds of critiques and they say, well, it's colder, it's not hotter?
Right. So one thing is weather. The other thing is climate, right? So weather is day to day, right? You get your weather forecast, and they can forecast that out to a couple of days. Now, when you're talking about climate, that's something a bit more permanent, that's characteristic of a certain region, long-term characteristic. And so what we're looking at is how the climate is changing. The fact that today is colder than usual it's not necessarily an indicator of things not happening, right? So you have to look at the long-term average, and that is really what tells the story here. So if you look at how temperature is changing in the last couple of decades, if you look at how sea ice is changing in the Arctic in the last couple of decades, if you look at sea level rise in the last couple of decades, then that really tells a story. Everything is telling us that things are changing, right? So all the symptoms are there, that there is a big change going on in our planet.
And that's really what global warming and climate change is about, which is much greater than the weather, which people, that's what they see in their own communities, but they don't necessarily see the bigger picture. They don't see the melting ice. They don't see those pictures of, the polar bears on little pieces of ice. They don't see the, like you do when you go to the northern high latitudes and you see the vegetation growing where there should be more ice, right? Those are the things, those are the facts that you see, that you put together with all your data to come to the conclusions that you do. So the scientists seem to be saying that we've got to get our act together in the next 10 years. Is that right? We need to really transition away from, for instance, fossil fuels in the next 10 years?
Correct. So the main culprit for global warming is an increase in greenhouse gases. So if you think about it, our atmosphere is a layer of gases that surrounds our planet, and some of these gases are greenhouse gases, and these greenhouse gases, they retain heat. It's natural. It's a natural part of Earth's system. If it weren't for those greenhouse gases, Earth would probably be too cold a place to live.
Yeah.
But we are increasing the concentration of those greenhouse gases, especially carbon dioxide. And that is causing our planet to warm. So we're increasing that blanket, that capability of Earth to retain heat. And that's causing all of these other effects, the melting of ice, the increase in sea levels, the just ecosystems are being affected. All this havoc. So that's climate change. So we need to do something about it to stop the acceleration of the effects that we're seeing.
Yeah. It's
Yeah.
And what do you think that what is NASA actually doing now? I mean, because you've talked about the different satellites that started with the Smap program 5 years ago, which this is its 5th year. And you talk about sensors in technology. You talk about eco stress and about the International Space Station. And would you talk about some of those different projects that NASA's working on?
Yeah, absolutely. So NASA's focus is on the observation of Earth through satellites primarily. And so NASA has a fleet of satellites in space that studies the different components of our Earth's environment. So it studies the oceans, it studies the atmosphere, and the continents, terrestrial ecosystems. And so JPL has a number of satellites up in space. When we first met, I was working on SMAP, the Soil Moisture Active Passive, which is just celebrated its 5 years since launch, and it's been generating information on soil moisture globally. So it's been a very not only a successful mission, but it's been very exciting for me to be part of such a mission, because it's a unique vantage point to be able to study our planet from space. You can study the entire planet on a continuous basis, and you can monitor how things are changing, whether for good or for bad. And JPL also has a number of other sensors. So it's not just about satellites, but we call them sensors in space. And we've been using the International Space Station as a platform to put some of our sensors, Earth observing sensors. And we've got one called OCO3, Orbiting Carbon Observatory 3. And that measures CO2, carbon dioxide concentrations in the atmosphere.
Wow.
And it also measures something else. It's called solar-induced fluorescence, which is plant health.
Oh, wow.
Or plant photosynthetic activity, which is an indicator of plant health. And there's also another sensor called ecostress. And ecostress was launched last year. It was placed on the ISS, International Space Station, last year. And it has a thermal camera, so it measures temperature of the vegetation.
Really?
Yes, and so vegetation, it can sometimes it can overstress, and so it measures basically vegetation health.
Wow. And so is it like SMAP, where with the International Space Station, does it go around the Earth twice a day?
So the International Space Station doesn't have a regular orbit like
I see.
SMAP. SMAP has an orbit where you can predict when it's going to come over, like every day. But the International Space Station, its orbit changes, and so it has observations of the same place during different times of the day. So it can observe the same spot, say, at different times in different days.
Oh, I see. So it doesn't have to be in motion. It can basically stay stagnant, or
No. It's not stagnant. It is in an orbit. It's just not an orbit that has a regular repeat over the same area at the same time.
Oh, I see. I see what you're saying. So they changed the trajectory of it, maybe.
Yeah. Yes, exactly.
Oh, I see. That's interesting. That's fascinating.
Yeah.
So, and these sensors are just devices that are inside the space station?
They're outside.
They're outside the space station.
Yes.
So when the astronauts spacewalk, if they need to work on them, they go outside and.
So no, they haven't. And to install them, it's also a robotic arm that installs them.
Oh wow, wow, technology is amazing. What's happening now.
Yes, and it's been really quite an opportunity to put these sensors in a platform like the International Space Station. So they're already doing like amazing science in the space station, and now to increment that with these sensors outside is really great.
Fantastic. Do you think you would ever go to the International Space Station?
Maybe as a tourist.
That would be fun.
Yeah.
They could certainly use your insight. That's for sure.
Oh, well, I hope so.
Yeah, that's fantastic. Now, going back to the Earth itself and biodiversity, you mentioned to me that we are in the middle of a mass extinction again. Can you explain what you meant by that?
Yes. So biodiversity is something that I've started working on recently. And it's of great concern because biodiversity is being lost very quickly at the moment in our planet. And one of the things I mentioned to you was that we believe, or scientists believe, that Earth is undergoing its 6th mass extinction. So what does that mean? That means that we are losing biodiversity, we're losing flora and fauna at a rate that has not been seen since the dinosaurs were wiped out of this Earth.
Oh, wow.
66 million years ago. Yes, so that is the accelerated loss of biodiversity that's currently going on in our planet. And the main reason for that loss of biodiversity is because of human activities, because we are destroying habitats, both on land and in the ocean. In the ocean, we're overfishing, we're destroying corals. On land, forests are being cut for grazing, for agriculture, and biodiversity is being lost at a quicker rate than we can even document it.
Wow. Let alone replenish,
Correct.
restore.
Correct. So there's been some dire warnings from international agencies about needing to do something very quickly in order to slow down this massive loss of biodiversity that our planet is currently undergoing.
And I know that it has a lot of economic ramifications too, because I've studied a little bit of that. I talked to one of the originators of the original Green New Deal in 2007, and there's a lot of economics that goes into that, and planning that, and planning how you create that 10-year transition, right? Because you also have to think in terms of people need jobs, and as well as how the technology is going to make that transition that has to be made. And same thing, with animal agriculture because of the methane, right? Because and then the fires that we've seen in Brazil and Australia on a massive scale. I mean, we're losing some very important. In Brazil, we're losing a lot of the rainforest, the tropical rainforest that we need to maintain the biodiversity that you're talking about, right?
Correct.
And so and thinking in terms of, how long would it take to restore that?
It might not even happen.
Yeah.
It's in many cases, species are lost, and they're just lost forever, and that is very concerning. I mean, you talked about the wildfires; they were huge in the Amazon, in Australia. They were massive, and I read that 500 million animals were lost. Many of them were probably lost forever.
Yeah.
A lot of species were just lost forever.
Yeah.
And habitats destroyed. I mean, even the ones that survive, for them to come back to healthy populations will probably take a long time.
Yeah. I know you and I have talked about, some of the simple things that we can do, but it's really not enough. I mean, we need to continue doing it. Recycling, reducing, reusing. But in addition to that, what can we do now to help move this activity forward faster, to help the transition happen faster? I know we mentioned before we started taping, we were talking about these young people like Greta Thunberg, that are really drawing awareness globally to the urgency of this, and that the young people are really taking a hold of this, the different groups, the Sunrise and the Extinction Rebellion, and they're really doing the work out there to raise the awareness. They're doing phenomenal work out there. So that's the kind of thing we need, I think, going forward. But also, too, from the scientific standpoint, from the economic standpoint, I think it makes sense to me we need to build coalitions in every possible way, so that we can put the pressure where it needs to be, so that the funding can be there to actually get these things done. But first, people have to understand the urgency of the situation. What more, in addition to what we're already doing, do you think we should be doing?
Well, I think the most important part is for people to educate themselves, and that's where we as scientists come into place in terms of studying our planet from the unique vantage point of space and understanding what's going on. I personally think that you can do a lot of little things in your life to just reduce the amount of resources that you use, right? And just be aware of the water that you use, the electricity, the fuel that you use in your car, just little things that you have the power to control, the things that you buy, choices that you make in terms of political choices or any sort of choice that you make, indirectly or directly has an environmental impact.
I can't think of the name that we were just talking about him, the Dutch kid.
The young Dutch, yeah.
And he was saying something like, on another podcast by a guy named Joe Rogan, he was saying something about there's a whole the size of size of Connecticut out in the Pacific Ocean, just plastic and pollution. And I'm like, the average American couldn't even fathom that, and that we all have probably in some way contributed to that. So we have a responsibility to be aware of that. We have a responsibility for future generations. That there actually won't be such an extinction that that there's no turning back. And so this is to me a matter of urgency. We all need to use our talents and our skills and our knowledge and just put them to use. And the more that we do that, the faster I think we can see a response. That's my personal thinking.
Yeah, no, I totally agree. And I think I personally believe that change begins at all levels, from the grassroots level up and from the top, the government level down. And if it might not seem much for you to change your habits, reduce 10% of your consumption, the resources that you consume. But if everyone did that, that's 10% of the problem that you're solving.
That's right. That's absolutely right. And that's right. That's what people don't realize is that there's a great quote from Nelson Mandela that says, everything is impossible until it's done. And I like that a lot. It makes me realize that, you can think that there's just no way. There's just too much and it's too late. But at the same time, it is possible. It is possible, and it seems impossible until it's done.
Yes.
And that's kind of my mindset towards this is that, but we have to act now. I mean, we really can't wait, and which would explain why there's a sudden explosion in everything, in the climate rallies, the awareness of the crisis, the political connections, the economic research that's been done, the budgeting that's been done about how to do this, and where the money's going to come from. I mean, all of this work has been done, and of course, we have to be the ones that say, "Hey, look, everything is there. It can be done. You just have to change priorities, right? The money's there, the research is there, the science is there. It's all there. We just have to change the priorities of how we fund things, and that's where the politics comes in, unfortunately, and we have to bring it all together somehow, some way. Let's wrap this up. We want to get into some fun stuff here too. There's JPL does more than just climate science. You also have this is the year of the next mission to Mars. Is that right?
That is correct. Yeah. So even though I'm a Earth scientist, I can't help but have this great enthusiasm about all of the other missions that JPL is leading in terms of planetary missions. And there's a really exciting one this year called Mars 2020. So it's the next rover on Mars. And that's going to be launching sometime in July, August of this year. And there's going to be a rover. I don't know. You probably remember Curiosity. That
Yes.
was back in 2012. It looks similar to Curiosity, but it's got a number of different scientific instruments. And it's going to be very exciting to go and explore Mars in different scientific ways. And so that's one of the exciting missions. Another one that's been already out there for a while is called Juno. Juno is studying Jupiter, but one of the cool things that I find about Juno that gets me excited is there's a citizen science component to it.
Oh, really?
There's something called Juno Cam. And so the general public can go in there and vote on what they think the Juno Cam should image next.
Oh, fantastic.
Yes.
So, like, what would be an example of something like that? That, like, say, if I were to go on there and say, I want to see,
The big red dot, for example.
yeah.
Yeah.
You want to see? I want to get closer shots of what that looks like.
And if enough people have suggested that, that will probably be the next place that they focus the Juno Cam on.
Oh, I see. That's interesting. Wow, that's fantastic. I mean, the things and Jupiter has moons too, right?
Yes, it does.
Isn't there a Phobos?
And no, that would be Mars.
That's Mars. That's right. That's right. That's right. Yeah. But that's just mind-boggling to know that we're getting close-up shot. Do we have a lot of surface shots yet of Jupiter?
So Jupiter is one of those gas giants, but there are a lot of images. It's got a very thick atmosphere, so there are a lot of images of the atmosphere and of the pole, and the big red dot has been imaged, and just these amazing patterns of storms. It's really incredible. You should really go in there. Art and science kind of come together there because it's just like beautiful.
Yeah, and I know that the lead guitarist of Queen, the guitarist of Queen, I should say. There's only one guitarist. He has a doctorate in astronomy.
That's right.
And I have his book. I should have brought it tonight. I thought about it. And there's a lot of Hubble pictures in the book, and they're you're talking about artwork. It's phenomenal. It looks they could be paintings, and yet they're photographs.
Yes.
You know, it's just fantastic to see things that before we just imagined when we were kids, and now we can actually see real photographs of them. It's pretty amazing.
It is. It's mind-boggling.
It really is. And there's also JPL has a training program, right, for young people?
Yeah, so JPL has an internship program, and every summer, hundreds of students come to JPL for 10-week internships. It's a great opportunity for students to come and get some hands-on experience and learn about what JPL does and get themselves out there and be seen. That's how I started.
Oh, really?
Yeah, I started out as a student, and that was my opportunity to get my foot in the door, and that brought on other opportunities. And so the internship program, that's open right now. The applications are open. I believe they close on March 30th of 2020. And so, any students out there that are interested in doing an internship at JPL should really seriously consider applying.
That's fantastic. That's good to know. And young people are really excited about this kind of stuff.
Yeah, they are. And usually every summer I'll have 2 or 3 students working with me. And
wow,
it's really it's invigorating for me to work with students because they bring in such enthusiasm.
And you were in that position once yourself.
That's
so,
right. Yeah.
And well, Erika, we could talk on and on and on. It was really great seeing you. Thank you so much for coming back on the show and giving us an update. And you will come back.
I will. Thanks for having me back, and I'd love to come back. Yes.
That'd be fantastic. And we can delve in what's going on from here on, and maybe have a panel or be part of a panel, or maybe we'll be creative with it. We'll see what we can come up with, to get the word out and talk more about these issues as we go forward.
Yeah, and I think that's important.
Absolutely. And everything is important right now. We need everybody on board, bringing all of our resources together, and we can learn together and from each other. And so thank you so much. And this is Niswander here with Erika Podest. Erika, before we wrap it up, what's some websites and where people can get more information about your work and also NASA?
Sure. So
JPL.
Yes. So Jpl.NASA.gov. There's a Climate.NASA.gov. I talked about Smap. Smap.jpl.NASA.gov. However, if you go to the main webpage, the main JPL webpage, and you do a Google search on Juno or Mars 2020, you'll go to any of those landing pages for those missions.
Fantastic. Thank you so much, Erika. And thank you for watching The Nowman Show, and always stay present in the moment. Now.